Hi everyone. In this small video, I would like to solve a problem which is based on the topic of radius of curvature. But before I solve that question, let us understand the concept of radius of curvature. Let's say a particle is going in a circular path. Now at any instant, here let's say its velocity is along the tangent and acceleration could be anywhere, but let's assume it is somewhere here. This is the acceleration. Now, if you take components of this acceleration, one parallel to velocity, which I will write as at, tangential acceleration, then the other component will be perpendicular to velocity, right? And this perpendicular component will obviously pass through center of this circle, right? Because tangent and radius are perpendicular. So this component is your normal acceleration, or it is also called centripetal acceleration. Now, to find the radius of this circle r, you just need to remember this formula. Centripetal acceleration is equals to v square by r. So r will be what? V square by AC. So to find the radius, what we should do? Divide the velocity square at this point by the component of acceleration which is perpendicular to velocity. Okay. Now in this case, I took a particle which is going in circle, but let's say you have a particle which is going in a parabola like this. So it's a parabola, it's not a circle. However, at any instant here, if you see, the small part here can be imagined as part of some circle, isn't it? Any small part can be thought as part of a circle. And how to find the radius of that circle? So, a very similar formula we have. So, if you want to know the radius of curvature, this is called radius of curvature at this point P, let's say, then what you should do? Just find the velocity here, find the acceleration which is perpendicular to velocity, which is centripetal acceleration, then divide v square by AC. That would be the radius of curvature of this parabola at this point. Similarly, at this point you can see it is more curved here, right? More curved. So if it is more curved, radius will be smaller. So here also find the velocity square, then divide by the centripetal acceleration AC. Dash, let me write. So dash is for this point and without the dash is for this point. So that way, for any point, we can find the radius of curvature by using this formula. Okay. So now let's try to solve the actual question. Okay. So at time 0, they have given velocity of the particle is 8 meter per second. Acceleration is given 2 meter per second square, which is a constant vector. Constant vector here means magnitude and direction of acceleration remains constant. You have to find the minimum radius of curvature. Minimum they told. Okay, be careful. So some of you may think, okay, velocity is given, acceleration is given, and the angle between them is 150 degree. So you may think you will take components of acceleration, one here, right? Now if this is 150, this will be 30 degree, isn't it? Because total is 180. So this component will be a cos 30. This will be a sin 30. Now, which component is perpendicular to velocity? This component. So, this is your AC and this must be your AT, right? So, you may think the radius of curvature will be velocity here, which is V naught square by centripetal acceleration here, which is A sin 30. Now, this is correct, but this is the radius of curvature at this instant, which is time 0. They are asking you minimum radius of curvature, not initial radius of curvature. And here the radius of curvature will change. Why? Because you can see this acceleration is opposite to velocity. So obviously with time this particle will move slower because acceleration tangential is opposite to velocity, right? So it will move slower and slower. So at which moment the radius will become minimum, they are asking. Well, the radius will be minimum when velocity also becomes minimum, and this component should become maximum. So if numerator is minimum, denominator is maximum, ratio will be minimum. So now the question is how to find the time when velocity is minimum. Well, they told that acceleration remains constant in direction and initial velocity was here. This whole angle was given, remember, 150. So if I treat this line as x-axis and this as y-axis, then since acceleration is constant along x-axis, it means along y-axis acceleration must be 0. Therefore, velocity along y-axis must remain constant. What about velocity along x-axis? That will change. Now question is it will increase or decrease. For that, take components of this initial velocity. One let me take along x-axis and other one let me take along y-axis. This was given 150. So this is 90. So this must be 60. So this component will be V naught cos 60, which is V naught by 2. So this velocity will remain constant, V naught by 2. Whereas velocity along x will decrease. Why it will decrease? Because this velocity you can see is opposite to acceleration, right? So this velocity decreases because velocity is opposite to acceleration. Now you know that velocity at any moment is given by root over vx square plus vy square. And since we want this velocity to be minimum, here which component will be minimum? Well, vx is decreasing. So this will become 0 when this is minimum. So when this will become 0, velocity will be minimum, and that minimum velocity will be simply your y component of velocity, which remains constant v naught by 2. So if they ask what is the radius of curvature minimum value, then that will be v minimum square by centripetal acceleration, isn't it? And v minimum square means how much? V naught square by 4. Substitute this here. And centripetal acceleration will be what? Well, when Vx is 0, that time your V will be minimum. And if Vx is 0, there will be only this component of velocity. Only Vy will be there. Isn't it? And for centripetal acceleration, we need that component of acceleration which is perpendicular to velocity. Here this itself is perpendicular to velocity, right? This is your minimum velocity, remember. So you can see in this diagram that centripetal acceleration is this a itself, which is given in the question as 2. V naught was given 8, divided by 4 2s are 8, so answer is 8 meters. Well, in this question, they did not ask the time when the radius will be minimum. But if they ask, how will you do? Well, radius will be minimum when velocity is minimum. That happens when Vx is 0. What is the formula for Vx in kinematics? We learned Ux plus Axt. Right? A is constant, so we can use this formula. And where is initial velocity along x-axis? It is in this direction, which is equal to V naught sine 60. Right, one component is v naught cos 60, other component is v naught sin 60, which is v naught root 3 by 2. So this vx is v naught root 3 by 2. Acceleration ax is where? It is in this direction, opposite to this positive direction. So minus 2 t equal to 0. So if you take it that side, v naught root 3 by 2 will be 2t. So t will be equals to v naught root 3 by 4. and v naught was given 8. So if you substitute 8, you'll get 2 root 3 seconds. So at this moment, 2 root 3 seconds, your radius will be minimum. Okay. Now let me give you a bonus topic. Okay. If they give you velocity vector and acceleration vector, how will you find radius of curvature? So these two are given in component form, okay? Like 3 I cap plus 2 j cap, and this is given as, let's say, 1 I cap minus 2 j cap or something like that. Then how to find radius of curvature? So if these two are given, how will you find radius of curvature? So for that, just now I told, let's say this is your acceleration vector and this is your velocity vector. So you need to take components of this acceleration, one parallel to velocity, one perpendicular to velocity, and this is your AC. So now how to find this AC in vector form? That we have to think. Well, if I take cross product of V and A, let's see what we will get. So this is VA sine theta with some unit vector, right? You know the formula A bar cross B bar. AB sine theta, some unit vector. So if I put modulus, then I don't need to write the unit vector, isn't it? Now look carefully. If this is theta, then this component of acceleration is A cos theta. This is your tangential acceleration. And this component of acceleration is A sine theta, which is your AC. So you can see this guy is nothing but AC, isn't it? In magnitude. So what will be AC? Mod of V cross A divided by V. So finally, the radius of curvature formula will be V square by AC. V square by AC. What is AC? Mod of V cross A divided by V. So this will become V cube. And V can be also written as mod of V bar cube by mod of V cross A. So this formula you can use to find the radius of curvature. Let me give you one more bonus topic. Suppose I throw a particle with velocity u at angle theta with the ground. Gravity is, let's say, downwards. So here u will have two components, u cos theta, u sin theta. And as the particle moves in a parabola, you know at the highest point, its velocity will be completely along ground. So this is your v, which is completely along vx, because normally we write here x-axis and this one as y-axis, isn't it? So since this velocity is completely along x, here there is no vy. There is no vy. And all this happens why? Because your acceleration due to gravity is completely along y-axis. So there is no x component of acceleration. So this velocity will not change and this velocity will decrease. Why? Because initial velocity is upward, acceleration is downward. Very similar to the problem which we solved. There also initial velocity along y-axis was opposite to your acceleration, right? So and after you understood everything, if somebody will now ask you along this path, where is the radius of curvature minimum? Where will you say? Along this path ABC, where is the radius of curvature minimum? Where will you say? Obviously here, because at this point one of the component of velocity is 0. So only Vx will survive. So Vx is, you know, ux, it remains constant, and ux was how much? U cos theta. So here the radius of curvature will become velocity square here, which is u cos theta whole square divided by acceleration, which is perpendicular to this velocity. Acceleration perpendicular to this velocity is the entire acceleration due to gravity only. So divided by g. So this is your minimum radius of curvature in projectile motion, right?